And you can do it with any multiple. You can do it with 3s, 5s, 2s, whatever. Okay, you can even do it with fractions, I guess, if you want to be really mean. So look out for those kind of questions. Really common one. Not too bad once you break it down. You just got to know smallest, largest, use that to find n, the number of the term, and then we can use our formula. Okay, so now recursive series, the idea of a recursive sequence, so writing a sequence as recursive, or writing a term as recursive, we looked at last lesson. And that was basically to say that if I want to find some term, so Tn, well, that's just the term before it, plus whatever the difference is. And remember at the end, we always wrote where T1 is whatever my A value was. So that was recursive in sequences. It's actually a little bit more useful in series. I'm going to try and show you how. So we're going to kind of jump straight into an example because I think that's the best way we're going to get over this one. So given an equation, so they've already given us an equation for a series, which is this 2n squared minus 5n. We could calculate the sum of any part of the series. Great. So we can just pop in an n value. That tells us that the 13th term, or sorry, the sum at 13 is this answer. Okay. If we want to write the sum of a term based on its previous term, now this is the whole idea of a recursive formula. This is the recursive bit. Okay, we can say that the sum at that n value is the sum at the value before it, makes sense, plus that term. Now that's the difference between the arithmetic sequences and series, because the series is adding on each term as we go. If I am writing like S, so the sum at 8, well, that's going to be the sum at 7 plus whatever the 8th term is, because I need to add that on to get the 8th sum. Okay, so I'll show you why that's useful. So with that same formula, I want to find the second term. Oh, that's not what I wanted. Second term. And then I'm going to write an expression for any term. Okay, so I'm starting with the series formula. I'm going to use that to find the second term. And then I'm going to go back and write it as an explicit rule for any term in the sequence. So kind of going between the two lessons that we've been working on. Okay, so to start with, finding the second term. Now you go, okay, well, where do I even start? Well, let's start by considering what would the second sum be? All right, if I do the second sum, that's just like popping in a 2 anywhere that there was an n. If you do that, you should get 2 times 4, which should be 8, minus 5 times 2, which should be 10. Okay, I would get an answer then of -2. Now you're going, well, what use is that? But think about and it's usually when I'm doing 2s is really useful. If I have the second sum, I can use the sum before it, so the first sum, to write it in terms of that sum and that term. I know this can be kind of confusing, but bear with me. We're saying to find the second term, I could set the second sum equals the first sum plus that term. So if I knew both of those things, so the second and first sum, because I already have that formula, then I could quite easily find what that second term was just by manipulating that equation. So if I've got the second sum or second series, whatever you want to say, then the first sum would just be popping in, again, wherever there's an n, popping in a 1. So I should get, what, 2 minus 5? I should get -3. Now, using this recursive formula, I can say that, well, the second sum equals the first sum plus the second term. And remember, what I'm trying to find is what's that second term. So you could probably answer it already, because you're saying to yourself, to get from this to this, what did I have to add on? And clearly you've added 1, which is going to be our answer. Spoiler, okay? But we'll use the formula. So if you popped in -2 and -3, and we've got this pronumeral to solve for, this second term, I'm going to do that by adding this 3 onto the other side, and I get that the second term was 1. So this often comes up when you're asked to find T2, right, the second term, because it's really easy to do in terms of that first sum. Let's do another example just like this, where we take it a little bit further and break it up a little bit more, okay? So this is going to be the last example we go through today. We have the sum of the first n terms of an arithmetic sequence. The sum, right? It's just a wordy way of writing it, is 5n squared minus 10n. Our first job is to find the value of a. Now, when we find a, you got to think about a is the first term in a sequence. If I'm talking sums and series, the first term is just itself because you haven't added anything on. So that is the same thing as the sum of the first term because it's just the first term. So all we're going to do is grab our formula and we're just going to pop in 1. So anywhere that there was an n, I'll actually write it out this time for you in case I confused you last time. We're going to pop in a 1. You're going to get 5 minus 10. So I'm going to get minus 5. That means the sum, the first term, a, it's all just minus 5. Because it asked me to find a, I'm going to write it as a equals minus 5. If they tell you to write it a certain way, it's probably because you're going to be using it later on. So now that we have our first term, it's asking us to find the value of the second term. Now, what I don't have is the formula, this first one up here, to find any term. And I also don't have the common difference, so I can't use that. I would need 2 terms to find that difference. I can't do that between sums. What I can do between sums is this recursive idea in saying that the second sum is the first sum plus that second term. Now I've already found the first sum just by popping in 1. I got -5, so that's going to go there. I'm trying to find the second term, so I'm going to leave that as the pronumeral. That's what I'm solving for. I just need to find, well, what is the sum at 2? Again, though, I have a formula, so all I have to do is pop in 2 wherever there was an n, and I should get 5 times 4 is 20 minus 20. So the second sum is 0. Again, at this point, you could probably just jump to the answer, and if you can, that's totally fine. You don't have to write the working out, as long as you're correct, obviously. So all we need to do now is we say, okay, well, the second, I'm just going to write this over here, but I'm not going to write the formula out again. I'm just going to pop in S2 as 0, S1, okay, was minus 5, and T2 is what I'm finding. Again, I'm going to get it on its own by adding this 5 onto the other side. And I get that the second term in this series is 5. Okay, cool. So now we want to find the common difference. So we've kind of started as a series question and it slowly transitioned into a sequences, which is kind of cool. So finding the common difference, remember, don't get scared because it's like part C. It's a really easy idea. It's just the difference between term 1 and term 2. And we do that by taking term 1 away from term 2. You could also just look at term 1 and say, well, what have I added to get from -5 to get to 5? Either way you do that, if I go 5 take away -5, you're going to get 10. And that makes sense because my first term was -5. My second term was +5. I must have added 10 to get between those. Now, the final thing it wants me to do is find a simplified, that means I'm going to have to expand it and do all that stuff, expression for t of n. Now, t of n, you go to your reference sheet under sequences and series, and you can see that it's going to be our first value, which we know, plus n minus 1. We're going to leave it in terms of n, that's fine, and our difference, which we just found. So all we need to do is come back here. Remember that a was our first value. That was -5 from that first question. D was 10, because we just found that. Then the term for any n value is -5 plus n minus 1 times the difference. Now, because it wants a simplified answer, all I'm going to need to do, expand those brackets, tidy it up a little bit. I'm going to get -5 plus 10n minus 10. Make sure you multiply by both terms. Now I can grab that 10n and write it out the front, and I've got -10 take away 5. So -15. And that is the simplified expression. So in terms of your work for this week, hopefully you've done either the maths base or the maths in focus questions for arithmetic sequences. You can see how they are a required skill before jumping into this, because it's going to go back and forward a lot. Again, you have the same choice. You can do a maths based task that should be up called Arithmetic Series. Again, that's going to have your answers. We explained the benefits of that last week. If you do maths in focus, it's chapter 1.03, so start of the book, pages 15 to 16. Now, the questions I want you to do a little bit different. Again, I've copied and pasted them here, so you could just use this. 1 to 5 is going to be the basics, which in this case is kind of helpful because this can be kind of confusing until you get it, and then you'll just get it. And then I want you to do 12 to 19, which is where you're going to doubt yourself because they get really tricky. So again, they're all here. You could just print this off, or you could do it on your tablet, whatever you want, or you can go to your book, whether you have a hard copy or whether you have a digital. Again, if you have any concerns, any issues, please let me know. We are trying to keep the pace up just because we don't know what's going to happen with the HSC yet. I'm recording this in advance, so if there's been something, awesome. Righto, let me know if you need any help.